Hello, let's discuss about the voltage, current, and resistance, and also the Ohm's law in this video. Voltage is the force where electrons get pushed. Current is flow of electrons. Resistance is where the electrons get restricted when they move along the conductor. The voltage, or it is also known as potential difference, the general meaning of potential is the ability to or achieve something for anything. In the same way, here the electrons in a power source are ready to jump or move towards the atoms, where the atoms are ready to receive electrons into their shells. These atoms are also known as holes. So, for example, a charger battery has electrons ready to join in atom shells on one terminal, and the other terminal has the atoms that are ready to let the electrons into them. To know more about electrons and how electricity actually works, watch my previous video. So, the terminal of battery where it has excess electrons is negative terminal, and the other terminal where it has atoms to let the electrons into them is positive terminal. Since the negative terminal is ready to lose the electrons and the positive terminal is ready to gain the electrons, now here this difference is known as the potential difference. The voltage or potential difference is measured in unit volt, named after an Italian physicist Alessandro Volta in 1881, with the symbol V, which means for a typical AAA battery, the voltage between the two terminals is 1.5 volts. To measure the voltage, we need to connect the terminals of multimeter, voltmeter, etc. at any 2 points in the circuit parallelly. I will make more detailed video on parallel series circuits in future videos. So make sure to subscribe and turn on the notification bell so you won't miss it. The standard voltage that gets into households is mostly either 230 volts or 120 volts depending on country to country. Countries such as United States, Canada get 120 volts for most of household appliances. The countries in Europe and many other countries get 230 volts into their most of the households. And all of these households get AC or alternating current. We will discuss more details on alternating current or AC and direct current or DC in the next video. Now here let's discuss about current. Although the word current in general has many meanings according to the situation and action, but in electricity the current means flow of electrons, and the current is measured in unit ampere. Named after French physicist and mathematician Henri-Marie Ampère in 1881. Ampere is also referred as shortly amp. Also, the current is represented with the capital letter I. Now let's take a circuit. The battery has voltage of 1.5 volts, and if the light bulb is rated as 1.5 watts, it requires 1 ampere of current to draw from the battery, which also means it requires to draw approximately 6 quintillion 242 quadrillion electrons, or 6.242 into 10 to the power of 18 electrons every second, which is also equivalent to 1 coulomb of charge. And of course, if the light bulb is rated as 3 watts, it requires 2 amperes of current to draw from the battery, which means it requires to draw approximately 12 quintillion 480 quadrillion electrons, or 1.248 into 10 to the power of 19 electrons every second, which is equivalent to 2 coulombs of charge. Current can be measured using the instruments such as multimeter, ammeter, etc. by connecting their terminals in series in the circuit. Now, the resistance. The general meaning of resistance is objecting or opposing someone or something, or fighting against something. Then in electricity, the resistance is opposing the flow of electrons. What I mean of opposing electrons is in conductors there are more free electrons to flow. The free electrons in the conductors are less bound to their atoms. So the electrons are more free to move, which means the resistance is low. But in insulators, the electrons bond strong to their atoms. So no free electrons or very less free electrons to move, which means they restrict or don't allow electrons to flow through them. Hence, the insulators provide high resistance. The unit of resistance is the ohm, named after German physicist and mathematician Georg Simon Ohm in late 19th century. And the symbol for ohm is the upper Greek letter omega. Different materials exhibit different resistances. Like the conductor copper has low resistance, the insulator rubber has high resistance. The longer the conductor, the higher the resistance. It means if the length of the conductor increases, the resistance also increases. For example, for a 10 centimeter length and 1 centimeter diameter of copper conductor has 0.000214 ohms of resistance, then for a 20 centimeter length and 1 centimeter diameter of copper conductor has 0.000428 ohms of resistance. The larger the cross-sectional area of the conductor, the lower the resistance. It means if the cross-sectional area of the conductor increases, the resistance decreases. And if the cross-sectional area of the conductor decreases, the resistance increases. The resistance can be measured by connecting the instruments such as multimeter, ohmmeter, etc. at any 2 points of the given material. If you want to measure the whole material, you should hold the terminals of the instrument at ends of the material because likewise resistance increases decreases with increase decrease in length and cross sectional area. Now the Ohm's law. The Ohm's law is simply V is equal to IR. V is the voltage, I is the current, and R is the resistance. The Ohm's law was proposed by the German physicist and mathematician George Simon Ohm. To say in the details, during the constant temperature, the voltage in the conductor of 2 points is directly proportional to the current in the 2 points, which means if the voltage increases, the current increases proportionally, and if the voltage decreases, the current decreases proportionally. Also, the resistance is inversely proportional to the current, where voltage remains constant, which means if the resistance increases, the current decreases, and if the resistance decreases, the current increases, where the voltage is still the same. The Ohm's law formula can also be written as I is equal to V by R and R is equal to V by I. By using the Ohm's law, if two parameter values are available, you can calculate the third one. Example, in a circuit, if the voltage is 5 volts and current flowing is 2 amperes, then the resistance can be calculated as R is equal to V by I. So by substituting the voltage and current values 5 by 2, we get the resistance 2.5 ohms. And remember, the Ohm's law is valid only when the temperature is constant, because if the temperature changes, the resistance also changes. Hope you got the idea on voltage, current, resistance, and Ohm's law. Thank you for watching this video.